Okay, I am holding the microphone right next to my mouth and I'm yelling, so hopefully you can hear this. Um, all right, what we're going to do today is talk about sort of the same thing we talked about when we were working with ratios, in that we know that if two shapes are similar, um, their perimeter has the same ratio as their similarity ratio. Their area has the same ratio as the square of their similarity ratio, and their volume has the same ratio as the cube of their similarity ratio. So if two sides were 2 over, the ratio of the sides was 2 over 3, the ratios of their perimeter would be 2 over 3, the ratios of their areas would be 4 over 9, and the ratios of their volumes would be 8 over 27. Perimeter, area, volume. So we're going to kind of talk about that in respect to the areas of figures. All right, so think about this for a second. If you take the area of this trapezoid, which is 1/2 base 1 plus base 2 times height, so that's 1/2 um, times 16 times 2. So 1/2 of 2 is 1. 1 times 16 is 16. So when the height is 2, the area is 16. Okay, now what if we triple the height? We leave the bases alone, but we triple the height. So again, we've got 1/2 base times base 1 plus base 2 times height. So 1/2 times 16 times 3 is 48. So when the height is 6, the area is 48. Okay, let's uh, let's do another one. If the to find the area of this parallelogram, it's just base times height. So 1/2 times 12, that's 18. So when the height is 1/2, the area is 18. If I double the height, I get 3 times 12. So I have a height of 3 and an area of 36. Okay? Or one more example, if I quadruple this triangle, 1/2 base times height, a half of the base is 2 times height is 1. So if the height is 1, the area is 2. When I quadruple the height, I have 1/2 base times height, so 1/2 of 4 is 2. 2 times 4 is 8. So when the height is 4, the area is 8. Okay, so can you kind of see a pattern here? Every time, whatever I do to that one dimension, now we're not changing the bases for the trapezoids. We're not changing the bases. We're not doing, all we're changing is the height. And when I triple the height of this first trapezoid, it triples the area. When I triple the height of this parallelogram, it triples, or sorry, I double the area of the height of this parallelogram, it doubles the area. When I quadruple the height of this triangle, it quadruples the area, right? 1 times 4 is 4, 2 times 4 is 8. So when I'm just changing one dimension, it changes the area in the same way. So changing one dimension equals the change in the area. Okay, now that works for every shape except a circle. So think for a second, why wouldn't a circle have the same relationship? if I change, let me get some space here. If I have a circle and I double the radius, so it started out as 2. So 2 pi r squared is, um, r is 2, squared is 4, times pi. So that gives me 4 times pi, right? Now if I double the radius, so now I have a circle that's 4. I realize it doesn't look like I doubled it, but so now I have 4 squared times pi. That gives me 16 squared, or 16 pi, sorry. So if you look, I've doubled the radius, but the area didn't double. 4 times 2 is 8, not 16. It went up by a factor of 4. So why would that, think about that for a second, why would, if I doubled the radius, it go up by twice what I meant it to go up by? And the answer to that is the fact that we are actually using 2 radiuses. See how we square it here? So really, this is 2 times 2 times pi. So we doubled this radius, just like we doubled the height of the shapes up above. But over here, we doubled 2 radiuses. Now we have 4 times 4 times pi. And so we get twice the effect that we got when we just changed the height in those shapes above. Okay? This would be the time when I say, does that make sense? Does anyone have any questions? So again, we're doing your homework tomorrow. So if this isn't completely making sense, you'll have a couple minutes to talk about it with the sub or with each other, and maybe you can make some sense out of it if it's not making sense. Okay, so if I want to, using that relationship, if I want to change change the proportions of the perimeter and the area using a ratio, okay? If I made this rectangle, it's supposed to be say rectangle. If I made it 3 times bigger, so that means I'm going to change this 5 to 15 and this 8 to 24. All right? And my original area, right, my 8 by 5, my original shape only has an area of 40 square meters. Okay? And if I had just tripled one dimension, like up here above where I just did change the height, I would expect, if I tripled the height, I would expect the area to triple. But I tripled both dimensions. Just like in the circle, I doubled both radiuses that I use in the formula. So I'm not going to expect it to go up by 3. Think about, take a guess. What do you think the area should go up by? Just jot it down on your paper. Just write a number down. Well, if I just actually calculate the area of the new shape, 15 times 24, I get 360 square meters. Okay? How much bigger is 360 than 40? Well, 360 divided by 40 is 9. So when I triple the height and triple the base, the area goes up by 9, right? 3 and 3. Does that sound familiar? Because another way to write 3 times 3 is 3 squared. And remember, area changes by the square of the ratio. Okay? So if and the same thing, if it's half as big, so instead of 5 by 8, I go up by 2.5 and 4, or I change it to 2.5 and 4. Take a second and guess what you think the area is going to go up by. Hopefully you said 1/4, because 1/2 squared is 1/4. And if I do 2.5 times 4, I get 10. And that is 1/4 of 40. Okay? So when I change 2 dimensions, it goes up by the square of the old area, or goes down by the square of the old area if I reduce the sides. If I change 3 dimensions, it's going to triple. Does that make, or it's going to cube. Does everybody see that? Okay, so when all the dimensions of a figure are changed proportionally, so if I change the height and the base by the same thing, then the perimeter and area and volume relationships will hold. So the perimeter ratio would stay the same. The area would square, it would be the square of the original, and the volume would be the cube. The change cubed. Okay? And that works when everything's being multiplied. Kind of the only one that doesn't, like, if you can't just change 3 things, is a trapezoid, because B1 and B2 are being added together. So if you double B1, you double B2, and you double the height, it's only going to go up by the square, because B1 and B2 are being added together. Okay? If you want to see how that works, you can try it. All right? The other thing is, let's say instead of doubling both things, we double 1 and triple 1. Okay? Instead of 5 by 8, we have then 10 by 24. Okay? So that goes up 240 meters. That becomes 240 meters squared, which means it goes up by 6. 240 divided by 40 is 6. And if you'll notice, this is doubled and tripled, so that gives me a change of 6. Okay? Just like, so when we doubled both, it was 2 times 2. When we doubled 1 and tripled 1, it was 2 times 3. Okay? So take a second and work this uh, really area. And this is a square. So those are all equal. And you can hit pause and take a minute and work those out. But here's the answers. The area originally is 25. If we double the area, the side lengths, if you double the area, so you go up to, so if you just double the area, I read that wrong. I thought they were doubling the side lengths. So if you double the area, so now instead of 25, it's 50. Okay, I'm just doubling it. I'm not quadrupling it, which would be the square of the change. So that means only one side is getting bigger, right? Or they're both only increasing by the square root of 2. Because square root of 2 times square root of 2 is 2. Okay? So if I multiply 5 times the square root of 2, because again, remember back up here when we tripled the sides, the area went up by 9. So the change in the sides was the square root of the change in the area. So the change in the sides is equal to the square root of the change in the area. So if you doubled the area, the sides would go up by the square root of 2. If you tripled the area, the sides would go up by the square root of 3. If you quadrupled the area, the sides would go up by the square root of 4, or 2. And if you change the area by 5, the sides would change by the square root of 5. Okay? Okay? Same thing here. To find the area, this is 36 pi. Okay? If you changed, the area is 36 pi. The perimeter, though, is 12 pi. Okay? What if you doubled the area? So you made this 72 pi. Okay? That means the area of the radius is going to change by the square root of 2. So you do 6 times the square root of 2, which rounded is 8.49. Okay, so the perimeter would be, let's round this to 8.5, because when we double it, that it's going to be 17, right? So the perimeter is going to change to be 17.5. Okay, and when you take 17.5 divided by 12, you get the square root of 2. Okay, 1.46 or something like that. Because remember, the perimeter changes by just the same ratio as the area changes, or as the sides change. So if the radius is going up by the square root of 2, then the perimeter is going to go up by the square root of 2. If the perimeter goes up by the square root of 3, if the area goes up by the square root of 3, the perimeter will also go up by the square root of 3. You're not going to square it or cube it, because the perimeter just changes the way the side lengths change. All right? Okay. All right, so that's it for today. And like I said, tomorrow we'll go back over this and we'll work on your homework. But to really try, like this is one of those days when you got to really think. So talk about, if you need to, talk among yourselves. If your sub is a math teacher, then they can help you get through this. And we will meet back here tomorrow. Thanks.